Hello there. In this video I'm going to show you how to replace the front panel in a vector sequencer. In this case we're going to take a silver panel vector and put a black panel on it. So you will need a few tools that come with the panel kit. That includes a 2mm Allen wrench, a metal hex socket, small one, and some 3D printed tools. We have a little lever paddle for getting the knobs off the panel, a square socket to hold the little metal socket, goes in just like that, and a small 3D printed hex socket. This is for the jacks, and a larger hex socket for the nuts under the encoder knobs. You'll also need one tool to provide on your own, a pencil with an eraser. And also handy, if you have it, are some lens cleaning fluid and a microfiber cloth. When you take the panel off, it's a really good opportunity to clean the OLEDs. So I'm going to start by turning the vector sideways and holding it in my left hand like this, my fingers grasping the main PCB. I'm going to take the little knob paddle and I'm going to nudge it in underneath each knob and lever it back to loosen it from the encoder shaft. And once I've done that, they pull off easily. And something to note is that the main 8 encoders all have a hex nut underneath them, but not the 9th encoder. I'm going to take the larger of the 3D printed hex sockets and I'm going to loosen these, probably about almost a full turn. And the nice thing about these 3D printed tools is they will not scratch the aluminum panel. Okay, I've loosened those and I can use just my fingers to unthread them enough to get them to slide off. Okay, I'm going to set those aside. And I'm going to turn the panel over so that the jacks are facing lower. And notice that I'm always working with the panel held at an angle with the working area that I'm working on below the OLEDs. That way, if something slips, it won't slide into this gap between the panel and the OLED itself. Okay, so now I'm going to take the smaller hex socket and loosen the hex nuts on the jacks. And then I can use my finger to rotate the hex nuts till they fall off the threads. There are also little washers under the nuts, so you want to keep an eye out for those. Also note that I'm working on this is just an old bath towel. You want to work on a table with something on top to pad the surface. One nice thing about the towel is it keeps parts from rolling away. Your install kit may come with a few extra parts, particularly these little washers, because those can sometimes run away and disappear. Alright, so I'm going to take these and set these aside. And so I've removed the knobs, the hex nuts under the knobs, and the hex nuts and washers for the jacks. Something else to note is that the two MIDI jacks are a little shorter than the others and they don't use washers. Okay, so the next step is to turn our attention to the 4 main mounting screws. And if you turn the vector on the back, you can see where these come through all the way through the back panel, and they have lock nuts on them. So I'm going to set the vector on edge, and I'm going to take the 2mm Allen key, and I'm going to always be careful when holding this because it's a metal part and you can scratch the front panel if you run it against the panel. So I always kind of use an index finger to protect it. And I just carefully thread it into the mounting screw next to the run jack. Okay, and then use a couple fingers to hold the panel in place. Now I take the metal socket as mounted on the 3D printed tool with the square post, and it's a little loose, so you want to keep an eye on it. Of course I have to do this. There we go. Alright, so use this to loosen the lock nut. Just about one full turn is enough, and then you can use your fingers to release it. Okay, remove the Allen key and set it now on the long side with the 3 mounting screws along the bottom of the panel facing up, and I'm going to hold that in place. Take this guy and get it back together. Loosen this one up. Move to the next mounting screw. Loosen that one. And then the last one. Okay, set that aside, set the Allen key aside, and again, I'm always rotating the vector so that the elements I'm working on are near the towel facing down. Okay, unscrew these guys with my fingers. Set them aside. Okay, so now we can lift the panel off of the module, and I'll just set it down and use fingers and rest them against the encoder shafts and lift the panel up, and I can set that aside. Now I'm going to take the new panel, just one of these lovely new black panels. I'm going to just quickly check to make sure that the hex standoffs, these 10mm height things, are snug. So I put a finger on the mounting screw in the front panel and just give it a twist with my fingers. Doesn't have to be super tight, just want it to be snug enough so it doesn't rattle around. And then I'm going to line up the holes for the encoder shafts, because those are the tallest, and just lay them on top. Okay, and then all of the buttons on the vector have some wiggle to them. If I take the panel off, you can see they can wiggle quite much. And sometimes they just like to sit at a little bit of an angle. They don't want to go through the holes easily. So that's where the pencil comes in. I'm going to lay this on, and of course that one just happened to be lucky enough to snap into place, but let's say that I've got a couple of buttons that are out of alignment. I just go around with the pencil eraser and nudge them until they want to go, and I cradle the vector in my left hand and use fingers on the panel just to kind of pull it just a little bit snug so there's a little tension, and you check that the posts are meeting the right holes on the main PCB. Okay, this button is a little off, so just give it a little flick with the eraser. Go all around, check all the buttons, make sure they're through the panels, turn it over, and make sure that the screws have made it through the PCB. We use black screws with a black panel, so they're a little harder to see. Okay, so now I'm going to set this on edge, and I'm going to put all the lock nuts on, just finger tight for now. Okay, now I'm going to take the 2mm Allen key again using my index finger to keep that tip away from the front panel itself. And now I'm going to snug up these lock nuts. They don't have to be super tight, just nice and snug. Now for the one next to the Run button. Okay, so those are the 4 mounting screws that hold the panel in place primarily. And then we go back and let's go ahead and do the jacks. So I need to separate out the little thin flat washers and puts those back on. And then remember that the 2 MIDI jacks don't get washers. So now we do the little hex nuts, and we do them just with fingers first. And the trick is you kind of do what I call layup. You kind of set it on the edge, and then you gently lay it over the top of the threaded post for the jack, and give it a little spin with the finger. Run my fingers along to snug them up a little more, and then take the smaller of the 3D printed hex sockets and tighten them up. And now flip the unit over again, and now we're going to put the hex nuts for the encoders back on. Snug those up a little bit, and then take the larger hex socket and tighten those. And again, no nut for encoder number 9. Now what I like to do is I like to line all the flats on the posts so they're in roughly the same direction. It makes putting the knobs on a little easier. And then the knobs are D shaft. They have a little flat area. You line that up with the flat on the encoder shaft and push those on. Okay, that's the last bit. So now we have a black panel vector.